haven't heard the talk yet, so you might change your mind by the end of this. So, thanks everybody for coming out. It's cold outside, and I thought I'd see 3 people showing up. It would be me, Lily, and where's Mark? And but apparently more people showed up, so I'm delighted to be here. Interrupt me, feel free to interrupt me. The goal is going to be to talk for maybe 15 minutes, and then I will open it up for questions. And if I can't answer questions, I'll tell you I can't answer the question. First, I'll try to make it up, and then if I see that you lost the answer, I'll leave it at that. But if I see that you didn't quite buy my answer, I'll tell you I can't answer the question. But I'm happy to look up some information for you. There are a lot of questions related to antibiotics. And the use of antibiotics, particularly in agriculture, has been questioned a lot. And so we can discuss those issues as we go through. So I'll tell you a little bit about what I do. I'm in the Division of Infectious Diseases, and I study sexually transmitted infection. But I veered away a little bit. I study gonorrhea, and drug resistance in gonorrhea is a disaster. It's a huge problem. But I veered away also a little bit from that, and I also study the microbiome. These are the bacteria that inhabit essentially our body. And the microbiome has a strong relationship with the emergence of drug resistance. And so I've gotten a lot more interested in the issues related to antibiotic use and drug resistance. So that's how I essentially got there. And so I titled this brief talk, Antibiotics, the Good, the Bad, and the Ugly. And so we're going to start with the good. And then the bad is going to be essentially a discussion about resistance. And then the ugly is going to be about the use of these antibiotics outside of human medicine. And there are a lot of unknowns there, but I think it's worth talking about these issues because it could potentially affect us, could be affecting us now, could affect, the next generation much more significantly. And I think it's worth discussing. So the good, I'm not going to spend a lot of time talking about the good, because when it's good, it's really good. And antibiotics have been amazing. After the introduction of antibiotics, it's had an amazing impact on public health in general. So after sanitation, after vaccines, I would put antibiotics in third place in terms of the impact that they've had on human health. That's the really good. And so when we talk about the bad and the ugly, I don't want you to forget about the good. I don't want you to leave here thinking that you shouldn't be using antibiotics or you shouldn't be taking antibiotics. That is not the message that you should take from here. The message that you should take is that antibiotics are really great when they're used appropriately in the appropriate setting. And I'll tell you a little bit later about my dad, but my dad is 94, and he's been on an antibiotic every day for the last 3 years. And I'll tell you a little bit why he's been on that antibiotic. And it's been a life-saving antibiotic for him. So again, I don't want you to leave here thinking that antibiotics are bad. But we have to talk about the bad and the ugly. So let's talk about the bad and the ugly. And what I want to talk about is essentially antibiotic resistance. Antibiotic resistance is probably one of the most feared consequences of the antibiotics that we use. And the way antibiotic resistance develops, when I say resistance, you have to think mutation. It is a mutant organism that becomes resistant to the antibiotic. And so I drew this very beautiful picture here. And it's scientific, highly scientific. But it tells the whole story of drug resistance. And so here I take this organism, and it's a bad organism. It's a pathogen. It causes disease in humans. And every bacterium divides. And the nice thing about bacteria is they divide in a way that essentially generates identical daughter cells. So the daughters look exactly like the mother. Or the sons look exactly like the father. There really is no difference between these bacteria. Now, that would be the case if the division was perfect. The problem is bacteria divide very rapidly, and so division has imperfections in it. And so as they're dividing, they're trying to make identical organisms. But what happens over time is you get these mutant organisms. So here they're described as the red mutants and the green mutants. And so these mutants will start dividing as well, and they'll generate mutant bacteria. And so what happens is you get a whole bunch of bacteria ultimately. And remember, this is happening within minutes. This is happening billions of times a day. And so ultimately what happens is you get a huge population of the classic non-mutated bacteria, and you get a smaller population, but many different small populations of mutants. And so one of the big questions is, why don't these guys survive better than the ones that aren't mutated? Because mutations can provide them with an advantage. Remember, survival of the fittest, right? And so the people that are most fit will wind up surviving. Same thing with bacteria. So the reason why these mutants don't go anywhere, don't really expand a lot, is because the fittest bacterium is the one that's not mutated. The one that's not mutated, we often refer to it scientifically as the wild-type bacteria. And so the reason why the wild-type dominates, the non-mutant dominates, lucky for us, is because the wild-type can replicate much faster than the mutant. Whenever a bacterium develops a mutation, it comes at a cost. And the cost that the bacterium pays is in its ability often to replicate. And so these mutants don't replicate as well as the wild type. And so you wind up with a lot more wild type bacteria, the non-mutated, than the mutated bacteria. Lucky for us, right? So this is under normal conditions. And so what are these mutants? So randomly, these mutants can be resistant to an antibiotic. By random chance, you have a population that can be resistant to an antibiotic. You have another population that's resistant to a different antibiotic. So you have all these small populations that exist within us that are already resistant to antibiotics by random mutation. So they're there. But they're small populations. Now, mutations can also happen in a different way. These bacteria tend to be somewhat promiscuous. They will accept DNA from other bacteria that are not necessarily pathogens. If these bacteria are closely related and these other bacteria die, they will release their DNA, and these bacteria that are here, the pathogens, can accept that DNA and become mutated. And so you can mutate either while you're dividing, or you can mutate by getting DNA from the outside. That, my friends, is drug resistance. So that's part one. That's the first story I'm going to tell you. I'm going to tell you two stories. The second story I'm going to tell you is about us. Now you think you're a human, but I can tell you that you're not. At least not by the cells that inhabit you. For every one human cell that you have, there are 10 bacterial cells that inhabit you. So you are mainly made up of bacteria. And they're amazing bacteria. They do a lot of great things. They protect you from harmful bacteria because they overcrowd the harmful bacteria. They also help you in absorbing nutrients, in digestion. They keep your immune system healthy and active to protect you from the bad bacteria. And these bacteria are often referred to as the microbiome. Good bacteria living on humans. The microbiome, there are so many bacteria, and where they exist the most is in the gut. But we also have them in the oral area, in the upper respiratory tract, on the skin. We're all covered with really good bacteria that protect us from the bad bacteria that can grow on the in the vaginal tract, women are protected from yeast and bad bacteria by the vaginal microbiome. And that's what I study, is the vaginal microbiome. And so these good bacteria are amazing. They really help us in so many ways. And so the problem, though, is this. These bacteria also, and so the good bacteria, the microbiome, are the ones that have smiley faces here. And so they exist in conjunction with the nasty bacteria. Luckily, we have a lot more good bacteria than we have pathogens. In fact, these good bacteria tend to crowd out the pathogens. So let's think about what happens when we take an antibiotic, right? So you come in and you're feeling miserable. And I can tell you, I felt miserable before. You're feeling miserable and you're having a cough. This is the perfect time to say this. You're having a cough, you're having fever, you're having chills, your nose keeps on running. You haven't slept well in 2 nights and you're like, I'm sick of this, I'm going to see my doctor. You go see the doctor and he looks at you and says, it's just a viral infection. But remember, you went to see the doctor and you waited 3 hours in the waiting room because they couldn't fit you in immediately. And so you waited 3 hours in the waiting room. You're even more miserable than you were when you walked through the door. And then the doctor looks at you and says, oh, it's just a viral infection. Go home, it'll get better in several days. And you look at the doctor and you say, you know what? I have spent 6 hours here waiting to be seen. And now you're telling me to go home and take Tylenol. That's just not going to work. The doctor looks at their watch and thinks, oh my, I'm already late for my subsequent patient. It's probably easier for me to write a prescription for an antibiotic. And so what do? They write a prescription for a Z-Pack. Everybody, who's had a Z-Pack before? Raise your hand, don't be shy. So they write a prescription for a Z-Pack, and they send you on your merry way. You go home, you fill that prescription, and you start taking the Z-Pack. No. So now what happens? Well, 2 days later you feel better. It has very little to do with the Z-Pack, but you're still taking the Z-Pack. What happens in reality here when you're taking the Z-Pack? Well, what you did is, and what the physician has done, is essentially giving you an antibiotic that gets rid of a whole bunch of the good bacteria, the microbiome bacteria. But in the microbiome bacteria, you have a bunch of bacteria, because they replicate just like the other bacteria, that are inherently resistant to the antibiotic that you were given. And so you're going to get rid of all of the bacteria that are not resistant, and you're going to keep all of the resistant bacteria. So now you have a lot of bacteria in the microbiome that are resistant. You say, fine, you finished the antibiotic. Now, how long do you think these resistant bacteria last in the microbiome? Here we're going to talk about the gut, because that's where we have data. How long do you think these resistant bacteria last in your gut microbiome from the time that you finish this antibiotic course? Let me know. What do you think? Shout it out. A week? Come on. Longer. A year? Longer. The rest of your life we don't know. Perhaps. But what we do know is at least 4 years after you take an antibiotic course, even if you take no other antibiotic, the level of resistant organisms to that antibiotic in your gut is much higher than before you started taking that antibiotic. So we're talking about years. So now what happens? You've got a microbiome that's shifted, right? And you have more resistant pathogens among your microbiome. Now you've altered the microbiome a little bit. And so what happens? A month later, you get colonized with a bad bacteria. Have you all heard of staph, the staph bacterium? You get colonized, let's say, with a staph bacterium. A similar bacterium is called an Enterococcus bacterium. There are many different bacteria. There are gram, other types of bacteria that cause urinary tract infection. You get colonized with these bacteria. Now what happens? These lovely microbiome bacteria that are now much more likely to have resistance will die out, will release their DNA, and now the pathogens that are there will accept these DNA, and the pathogen that wasn't resistant is now resistant. And so that's how resistance is propagated. So let me give you a real life example of this. That same patient that got a Z-Pack started feeling better. We're going to be a little dirty now, so bear with me. They start feeling better. They got better. Now their microbiome is enriched with these resistant pathogens. A month later, they go out, and they're feeling so good, they have sex with one of their partners. They get infected with gonorrhea. And now they have gonorrhea in their throat. It happens. Gonorrhea in the throat does not cause any symptoms. So they don't know that they're infected with this organism. There are many bacteria in the throat as part of the microbiome that are just hanging out, that are closely related to gonorrhea, but they're not a sexually transmitted infection. And so you get infected now with gonorrhea. These other organisms that are now resistant to the macrolide because we've taken that Z-Pack are there. They die. They share their DNA with gonorrhea that's there. Now the gonorrhea that's there accepts the DNA, becomes resistant to this antibiotic. You're still feeling great because this gonorrhea is not causing any symptoms. You go out, you have sex with your partner, and you transmit this resistant infection to your partner. That's how drug resistance develops. That's the bad part of antibiotics. What about the ugly part? So the one thing that I want you to take home from this bad part is that every course of antibiotics comes at a price. You're paying a price for taking an antibiotic. And the big question that you have to ask yourself, is it worth paying that price? In some cases, it's absolutely worth paying the price. Absolutely. In other cases, maybe not. The last bit that I want to talk about is the ugly. As you know, question, yes?
Children have insurance. They are often prone to infection. They take a lot of antibiotics. Did they do a study with the gut microbiome on children to see if those last a long time for them as well?
Yes, so what they did was they actually followed our beautiful slide. Oh yes, the question is, children, and here I'm going to say infants. Infants have a weaker immune system than adults, and that's absolutely true. Particularly very young infants before the age of 1, the immune system still hasn't developed. And so we tend to use a lot of antibiotics in infants. Is that the same thing that you see? So it's really interesting. If you look at, they did studies where they actually took infants from the minute they were born, and they got specimens, and they followed these infants over time for up to 3 years of age. And they got almost weekly stool specimens to look at their gut microbiome. So let me tell you where the big changes happen with infants and their microbiome. The first big change happens depending on whether the infant was born naturally or through a cesarean section. Infants born naturally have a very different microbiome than infants born to a cesarean section. It's interesting to look at epidemiological studies that have been done where they look at now adults that have asthma, for example, and they look back to see if those adults were born through a C-section or through vaginal delivery. And there's a strong association between asthma and being born through C-section. It's a purely epidemiological association. It's not a causative association, but it's very intriguing. So the first thing that comes up is whether you're born C-section or not. The second big shift in microbiome happens when you switch from breast milk to food. You see a complete shift in the microbiome. After you start on solid foods, the microbiome tends to stabilize. When do you see huge shifts in the microbiome of 3-year-old kids or less? When is the next big shift? When they get antibiotics. It's a huge shift in the microbiome. Now the microbiome tends to come back to where it was before the antibiotic, but it never gets exactly to that place. And if you give 2 courses of antibiotics, you're shifting the dial even further away from where it had been before. And so in infants, antibiotics seem to have the same effect as in adults. And in infants, there is a price to pay for antibiotic use. And so there's no difference between infants, it seems, as compared to. So again, it's about knowing the price that you want to pay. Is it worth paying the price? In some cases, absolutely. Give me that antibiotic. For my dad, absolutely. He's paying the price. He's been on this antibiotic for years, but that's, I think, what's keeping him alive. Other patients, perhaps not. The patient that went in with a viral infection, is it really worth the price that you're paying? And the answer would probably be no in that particular case. So the last bit, thank you so much. Anybody else? Okay, question.
If there's such a big difference between vaginal birth and cesarean section, has there been any efforts to inoculate cesarean section babies with the vaginal microbiome, and has that worked?
So the question is a great question. The question is, if we know that there are differences between infants who are born through cesarean section and versus through vaginal birth, have we tried inoculating infants with, the vaginal microbiota? And let me tell you, the answer is no. And the reason why is because we still don't quite know a lot about the vaginal microbiome. It's a fascinating topic. I am involved in the research on that topic. And I'm interested in looking at hormonal contraception and what that does to the vaginal microbiome. But we started off thinking that the vaginal microbiome was pretty stable. And we realized that perhaps in some women it's stable, but in other women it shifts drastically within hours. And so the question is, how do these differences in microbiome translate to differences in the infants? And so you have to do studies where you actually sample the mother, sample the infant, both in C-section and non-C-section settings to look at that. And I'm not aware of any studies that have looked at that just yet. Great question. Any other questions? Yeah. Yeah, great question. So the question is, what about probiotics? So let me tell you, we know so very little about probiotics. I think they are potentially very, very useful. The problem that we face with probiotics these days is that, one, there is no standardized composition of a probiotic. The other thing that we face, so we don't know, I can send you to the grocery store and say, make a probiotic, right? You tell me which one. There are at least a dozen on the counter. I say to you, I don't know. The problem is there's no standardization. You don't know what you're buying. The FDA doesn't regulate these things. You could be buying essentially yeast for all you know, or you could be buying essentially a sugar pill for all you know. There's been one study that's looked at all the studies that have assessed probiotics in the setting of antibiotics. So let me tell you, when you give somebody antibiotics, you can affect the gut microbiome. This allows an organism that usually doesn't cause problems, but that resides in all of us, to start causing a really serious problem. Have any of you heard about C. diff, C. difficile, Clostridium difficile? That organism is found in most of our guts. It doesn't do anything, but the minute you alter the good microbiome, that organism can actually become pathogenic. It produces a toxin, and it causes very severe diarrhea. And that diarrhea, in some cases, particularly in older sick patients, can lead to essentially death in not very rare cases. About 10 to 15%, it could lead to death. And so in that case, they studied to see if you give probiotics to people who get antibiotics, can you prevent Clostridium difficile from emerging? And so they gathered all these studies that used all these different probiotics for different durations of time. And they looked to see what happened. And lo and behold, the data suggests that you can reduce the risk of C. difficile infection by about 40% by using probiotics. Now, where's the problem with that study? You go back and you say, okay, so which probiotic should I use? And they say, we're not sure because we actually combined all of the studies together. So yeah, you can take them off. And so the sad thing about probiotics is that we don't know. Now, there have been a couple of studies where they've actually taken several different probiotic components, lactobacillus, Saccharomyces, a whole bunch of them, and they tagged them. They put a dye on them so they could track them. And they gave patients the dyes are not toxic. They gave people, healthy people, these probiotics, and they said, go ahead and swallow them. And then they tracked whether these bacteria that they were given actually stuck in the microbiome, became part of the microbiome. For many of these bacteria, they just pooped them out. They never became part of the microbiome. For others, they actually became part of the microbiome. So one, we have to figure out which bacteria in the microbiome are protected. Two, we have to figure out if these protected bacteria, how's the best way that we can give these protected bacteria. And three, we have to manufacture probiotics that are standardized. So that when I send you to pay $25 for a bottle, I know you're getting something meaningful. Now, I tell my patients to eat yogurt when I give them antibiotics. The problem is that yogurt doesn't contain nearly enough of these strains to be helpful. Apparently kefir seems to contain more of these, but I haven't seen any really good data on that. So I still tell my patients to eat yogurt, and I figure it's not going to hurt. It might provide some benefit, but I rarely tell them to go out and buy probiotics. They tell me, can I buy probiotics? I say, sure, you can go out. But I hate to make them pay money when I don't know that they're getting any benefit from what they get. So it's another great question. But I think probiotics are going to be very important in the future when we know more about the microbiome and know more about what causes health and disease with respect to these. Thank you. Any other questions? Yeah. Yeah. So great question. So the question is, what if the doctor gave a placebo? If the patient, remember we talked about our patient who had a viral infection, and the doctor really didn't want to give an antibiotic, right? And so what if they had given the patient a placebo? Let me tell you what I think the problem is with us doctors. And I'm going to be very honest with this, because I catch myself doing this all the time. We're busy, we see too many patients, and you get a patient, like the patient that I talked to you about, and you look at them and you say, listen, this is not easy, the viral infection to get better. And the patient says to us, I've been waiting here, I want an antibiotic, I don't feel good. Let me translate. The patient, when they're looking at us as a physician, they're not telling us, please harm me. I want you to harm me. What they're telling us is, pay attention to me, I'm not feeling good, deal with my symptoms. The only thing I know that helps is antibiotics, but I'm willing to listen. With doctors, they're not saying I don't care about you when they're looking at you. They're saying you're going to be okay whether you take something or not. What I always try to do when I see my patients who come in and I don't feel they need an antibiotic, I always say, I'm sorry you feel that way. I know you feel terrible. Tell me what's bothering you the most. And they say, the cough is keeping me up at night, and the body aches are killing me. And so I say, okay, this is what we're going to do. We're going to use this drug, and there's a drug called Tessalon Pearl that is a prescription drug that helps with cough. It is non-addictive, it has no side effect. So I write a prescription for Tessalon Pearl. And then I say, I also want you to take ibuprofen every 8 hours, or Tylenol every 8 hours for the next 24 hours. These medications help with the fatigue and the aches that patients have. And I say the good news is I don't have to use an antibiotic and destroy all the good bacteria we have. I have never had a patient argue with me on this. So the way we talk to patients really makes a huge difference, and it doesn't take that much time. So I think rather than giving them pure placebo, I think if you gave them things that make them feel better, they would not be requesting it. So it's a great question. Any other questions?
So do you think the gut bacteria affects our moods and behavior and how we think?
Great question. So the question is, do we think bacteria affect moods and behavior? And here I'm going to say specifically the microbiome. It's pretty amazing. The microbiome has been associated with mood disorders. Again, I say associated, I don't say it's causing mood disorders. There are emerging data in the field of psychiatry that links some mood disorders with the type of microbiome that you have in your gut. So the answer to your question is there appears to be some data to suggest that maybe that occurs, but we still need to look at it much more closely. There are data to link the microbiome with autism. There are clear data now to link antibiotics use and the microbiome with obesity. I don't know if you guys read the studies looking at mice, but what they did with these mice, so they took pregnant mice and they gave them a little bit of penicillin right before they delivered, and they kept giving the mother penicillin after she delivered the child and was breastfeeding. Very low doses of penicillin. And they had mice that they didn't give them penicillin. And they followed the infants born to these mice. Guess what? The infants born to the mice that got penicillin had a huge tendency to be obese. And the infants born to mothers that did not get penicillin had normal body habitus. They took the microbiome from the obese mice and from the regular non-obese mice, and they injected them in germ-free mice. They didn't give them antibiotics, they just gave them the microbiome. And guess what? The mouse that got the microbiome from the obese mouse became obese, and the mouse that got the microbiome from the non-obese mouse had normal body habitus. So this study was recently published in the last year, and it was several studies were recently highlighted in the New England Journal of Medicine. Now, what does that mean for humans? What does that mean when a woman is pregnant? When is that critical time period? We don't know yet. But clearly, there is an association with many different conditions and the microbiome. The other big association with the microbiome is with heart disease. Again, several studies and really important journals, including the New England Journal, have linked a type of gut microbiome with increased risk of heart disease in individuals who have it. And so there are many unanswered questions still, and I think the next 10 years are going to be really interesting in the field of microbiome.
Is there anything known about artificial sweeteners?
I'm sorry?
Artificial sweeteners in
Yes,
microbiome?
there was a recent study looking at the role of artificial sweeteners and the microbiome, and they have a huge impact, and that's the reason why it's thought that potentially it could lead to obesity and increased risk of type 1 diabetes. So yeah, you're keeping up on every week it seems that there's a new study on microbiome linking it. But again, with obesity, with these nutritional products, we have great data in animal models. In humans, we still don't have perfect data. There's a strong association, but it's still not a causative association. And I think I would highlight that when I talk about the microbiome, so that you don't think that the microbiome is the end-all, be-all. Thank you. Question?
So industrial agriculture has been using antibiotics in commercial livestock for decades.
Yeah.
So why is it so surprising that it hurts the microbiome in mice and pig?
So the great question is, agriculture has been using antibiotics for decades. And so that gets us to the ugly part of it. So can I give you a 2-minute thing so that everybody's on the same page with this? So as you know, the majority of antibiotics that are used in this country are used in agriculture, particularly with animals. Remember, I mean, none of you, this is not going to come as any surprise to any of you, that, you know, the way that we can afford to buy our chicken and our meat in the grocery store is because many of these agro-producers are essentially stuffing all of these animals in tiny, tiny spaces, dumping antibiotics in their feeds to prevent them from getting infection. Because remember, when you're in a small enclosed space, right? I put a bunch of people in a small enclosed space where they have to live with other people, but they also have to live with the waste product of these other people. Remember, waste product is gut microbiome. And remember, gut microbiome contains a whole bunch of bacteria. And now you're mixing gut microbiome from all of these animals that are in the same area. So these bacteria are having a field day. And so you really are pushing these bacteria, you're pushing the types of bacteria that you see to a resistant phenotype. Now remember, in this country, we still use antibiotics in feed. And the reason why we use antibiotics in feed is to keep the animals healthy. When you put them in a small space like that, they're going to get infected and they're going to die. And to prevent them from getting infected, you have to put antibiotics in the feed that they eat. And then, ultimately what happens is, they grow, they're not infected, and they're essentially killed and sent to the grocery store. Now, all of the waste that is generated from these animals ultimately makes its way to the environment. There are no, so sewage, human sewage, there are regulations on how it should be disposed of. For animal waste, the regulation just doesn't exist. So again, let me summarize this. They're using most of the antibiotics in animals, and there is no really good way of disposing of it. So guess what? They did a bunch of studies following the pathway of water or stagnant soil near areas that grow agricultural areas. And not surprisingly, they found very highly resistant bacteria, and they found traces of these antibiotics. Also note that the antibiotics that they use in feed are the same classes of antibiotics that we use to treat human diseases. And so now they've done studies looking at chicken, turkey, and meat that you buy at the grocery store. And about 50% of chickens that you buy at the grocery store have a bacterium called salmonella on them. And a significant number of the salmonella that's actually found on the chicken are multi-drug resistant salmonella. And so, the problem is that you're kind of stuck. There is a huge political force from agriculture, but from where else do you think is there a huge political force not to change this? Pharmaceuticals. They sell the majority of their drugs to agriculture. It isn't in their best interest to actually have agriculture stop using these drugs in animals. And so this is essentially what happens. The EPA tries to introduce something, and they get the lobbyists coming down hard to say no, 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 no. And so right now, there's very little oversight. I mean, we don't even know exactly how much antibiotic is being used in agriculture. We don't really know exactly how a lot of the waste is going and where it's going. It's the ugly part of antibiotics because there are many question marks. Now the big question is, and I don't want to forget, but I'm going to come right back to you and I'm going to try to answer your question. The big question is, what does it mean for humans, right? So the good news is, I mean, if these resistant salmonella were causing infection in all of us, we'd all be gone, right? I mean, we'd all be dead. So the risk to us from eating chicken, even undercooked chicken, is relatively low. Remember, not only do you have to ingest this bacterium, so cooking usually kills the bacterium, so you're going to be probably okay adequately. But not only do you have to ingest the bacterium, but remember, once the bacterium gets into your gut, it has to compete with the good bacteria that are there. And usually, it doesn't do a very good job competing. Thank you, microbiome. Another reason why you should limit your antibiotics use. Let me tell you a sad story. I'll tell you a sad story. This is a real story. So, and then I'll give you the data behind that story. So we had a young man who was actually the brother of the physician that works at our hospital, who had gone to visit India. 2-week vacation, was never sick, went to visit family, was never sick, had a wonderful time in India, and came back. 3 weeks later, he got a urinary tract infection. And suddenly, his blood pressure dropped, and essentially he developed septic shock from the urinary tract infection. Nothing unusual so far. He got admitted to the hospital. We treated him with the typical antibiotics that we use to treat these types of infections that we see in the city. Unfortunately, 24 hours later, he died. This was a young guy who really had no other medical problems. The laboratory called us and said, guess what? He's growing this organism that is resistant to all antibiotics. This guy does not have any healthcare exposures. He's not a physician. The only exposure he had recently was going to India. In retrospect, when you look at the data from India, and I don't mean to sort of focus on India, but that's where we have the data. There are many other countries in the Far East, in the Middle East, where we see the same problem. In 5% of the drinking tap water in Delhi, 5% of the tap water in Delhi contains multi-drug resistant bacteria. 5% of samples. And in India, just like in the US, they use a lot of antibiotics, both over the counter for human consumption and the use of antibiotics in agriculture. And so we're seeing a lot of very drug-resistant organisms that are occurring in the community, luckily not so much in this country yet, but in other countries. And this, again, highlights the importance. I mean, the theory behind what happened to this young guy is that he went to India, he drank something, he became colonized with this resistant bacterium. He did okay. He came back home. For some unlucky reason, this bacterium made its way into its bladder and ultimately into his blood. And we did not have any clue as to why this bacterium was so resistant. We had no indication as to why it's so resistant. We didn't give him the right antibiotic, and he died from this infection. By the time we figured out what it was, because remember, it takes the lab 3 to 4 days to tell us what these antibiotics are resistant to, it was too late. This is an extreme example. We don't see this every day, and the reason why it still sticks in my mind is because it was so troubling. But we do see it, and we're seeing it more and more. Now, when you come to me, to the hospital, and I'm seeing you on the infectious diseases service, I always ask you, have you traveled recently to the Far East? Have you traveled anywhere? Tell me where you've traveled. Because now it figures into the equation about the choice of antibiotics. If you come in and you're severely ill and you've traveled to a high-risk area, I'm going to choose a different antibiotic than I would if you were just hanging out in Baltimore and you're coming to see me. So it's really amazing how complicated these issues have become. Have I answered your question? Thank you. Question?
Okay, first of all, I'm told that turkeys have antibiotics, turkey on the
Yeah. So there were three questions, and I'm going to repeat the question as I go through. The first question is, do they still use antibiotics? Have they stopped using antibiotics? Now, I'm not aware of that, but what I can tell you is that you can buy from the grocery store products that have been, so remember, organic doesn't mean antibiotic-free. Organic means they haven't gotten antibiotics after the second day, I'm talking about chicken here, after the second day of life. But they could have gotten antibiotics on the first day, and they could have gotten antibiotics when they were still in the egg phase. So organic doesn't mean no antibiotics, but there are antibiotic-free meats that you can buy that are probably twice as expensive, but those are theoretically not given antibiotics. Now, the problem is, where these animals were raised and compared to animals that were given antibiotics makes a big difference. Because remember, the waste of animals that were given antibiotics, so they could easily be colonized with bacteria that are resistant from the animals that got antibiotics. So I'm not aware of any good data really looking at the difference between antibiotic-free and antibiotic-raised organisms. Now, I'll be honest with you, when I go to the grocery store, I suck it up and I usually buy antibiotic-free, but I have no idea if it makes any difference. It just makes me feel better. And a lot of things that I do in my life, it probably does nothing other than make me lose more money, but it makes me feel better. And my goal in life is to sleep at night. And if this makes me sleep at night, then so be it. So there's no scientific, background. The second question that you asked is had to do with, well, the third question that you asked, if I can remember that one. And now you'll remind me of the second question. The third question that you asked is about phages. So I didn't go into it, but I'm going to go into it now because you're asking. Bacteriophages are viruses. But bacteriophages are viruses that infect bacteria. And bacteriophages carry DNA that can contain resistance epitopes or resistance genes that when they infect the bacteria, they inject it into the bacteria and transmit resistance. I would lump it into the ability of bacteria to accept DNA from the outside. So bacteriophage is another way that they can accept DNA from the outside. So they exist. You thought you were the only one that could get a virus, but again, bacteria can also get a virus. Second question.
The second question was, I read a study where these pathogens are intelligent enough to do some things that are bad for us.
So I have not read this study, and I think it would be a tough study to prove. The big question would be, so the study that was read was that these pathogens potentially could alter our diet, could make us alter our diet in such a way that it would benefit them. I'm not aware of a study like that. And so I'm not going to comment on that, but the big problem with studies like that is what came first, the chicken or the egg? So is it the pathogen that altered the diet, or is it the diet that you eat that allowed the pathogen to get there in the first place? So that potential bias can be very difficult to surmount. So I don't know the answer to that. I hope you bought my argument, but I could be completely misleading. Any other questions? Yes?
Well, who's vegetarian, so better choice. But now I'm wondering, should I go to veganism? Because how much is getting dairy products?
So should I go into veganism is the question. It's a good question. Listen, my take on this is that the most that I do is buy antibiotic-free, and to be honest, when I go to a restaurant, I'm going to have a burger, and even if it's not antibiotic-free, I have no willpower whatsoever. I think overall, I mean, remember, they're now starting to use antibiotics too on plants to try and limit bacterial invasion of plants. But also remember, even if they don't use antibiotics on plants, they're using manure on plants to make them grow, and they're full of, But the good news is, with plants, usually you can wash them, and hopefully you don't get a lot of these issues. Now, should you go to veganism, dairy products may contain trace antibiotics. They may also contain trace levels of hormones, etc. My answer would be probably, at this point, I don't see any compelling reason to completely become a vegan. It's hard enough being a vegetarian in this world. And so, I tried. There are weeks where I went where I was like, I will become a vegetarian. And usually by week 2, I'm like weeping, running to the grocery store and buying my, ground beef. And so I think we have to, listen, don't leave here thinking that, oh my God, it's the end of the world. But leave here with a healthy dose of skepticism and say, you know what? Let me do some reasonable things to try and protect myself and my family. Let me try and cook my meat well. Let me try, perhaps, and avoid unnecessary exposures. So perhaps, and I'm pushing it here, but perhaps you might want to buy antibiotic-free this, that, or the other if you care enough. Beyond that, I have a hard time, the scientist in me has a hard time recommending that you become a vegan. I think you can make an argument for it, but I'm not yet convinced that that's the way to go.
Cooking eliminates pathogens. Does it eliminate antibiotics?
So cooking eliminates pathogens. Does it eliminate antibiotics? And the answer is, in general, yes. Now remember, let me just preface all of this. Animals that are given antibiotics are not supposed to be killed within a certain period of time after they're given antibiotics. Mainly because the thought is that you want the antibiotic, you want the liver or the kidneys, depending on which antibiotic you're given, to process these antibiotics and excrete them from the animal before they're killed. That's essentially what they say happens. The impact, I think, of antibiotics, getting antibiotics from a cooked piece of meat is much less than the impact that you can get from getting a resistant pathogen from that. And not just a resistant pathogen theoretically, but also potentially DNA from a dead pathogen. Because remember, DNA could theoretically be transmitted. You don't need the live organism to transmit the DNA. So the likelihood that antibiotics, because they found antibiotics in very small quantities in drinking water. They found antibiotics in very small quantities in water that you buy, mineral water, that you buy in the grocery store. Nobody knows what these minute quantities really mean. Nobody knows. And nobody knows what the effect of these antibiotics are on the microbiome, the gut microbiome. They're in minute quantities. And so the question becomes, how does this impact really our lives? And the answer is, I don't know. And so I would say, after this talk, you shouldn't go immediately and change your whole way of life. You should just become a little more cynical. My goal in this talk is to make you a little more cynical. I hope I've succeeded. Question? Fecal transplant. Oh, I love fecal transplants. They're amazing. So let me tell you. So going back to the antibiotics and developing this infection called antibiotic-associated diarrhea, Clostridium difficile, C. difficile. We use drugs to treat C. difficile. Antibiotics, of course. Antibiotics cause C. difficile, and we use antibiotics to treat C. difficile. And you know what the greatest irony is? So the antibiotic that we use to treat C. difficile is oral formulation of vancomycin. It's called vancomycin. And we give it in a pill, and patients take it, and in 80% of the time, the C. difficile will go away after 2 weeks of this oral antibiotic. Now, the great irony is, this same antibiotic, when it's given IV, intravenously, can cause C. difficile. So that's the ultimate irony of antibiotics. But stool transplants are very, very effective at eliminating C. difficile. So essentially, the concept behind it is you're taking a healthy microbiome from a donor and you're implanting it in somebody who has an unhealthy microbiome. Without using antibiotics, you could potentially get rid of C. difficile. And the answer is, you get rid of C. difficile. And now, there are drug companies that are working, because you know, the thought of stool from somebody that, even somebody that you love, is problematic. And so, you know, they try to filter things out and they try to clean it out, but really, how much can you filter out of it? And so the way it's given usually is through, I know people are eating, but too bad for them. They give it through an enema. They try to give it through an enema, so that, wow, another very effective way of giving it is by actually putting a tube down into the small intestine and getting the stool down into the small intestine. It makes its way down into the colon and it works very well. But trying to tell somebody that I'm actually injecting stool into your small intestine makes people very uneasy. They could even drink it and it would do fine, perhaps. We don't know. Nobody's ever tried it. But now drug companies are actually on it. They are making these capsules that you can take that will not dissolve in the stomach, but will ultimately make it into the small intestine and break down and release many of the bacteria that are found in a normal microbiome. There are at least 3 startup companies that are looking at that. So in the next 5 years, you know, we may be treating this infection in a very different way. This goes back to the question on probiotics. I think in the next 5 to 10 years, because this is a form of probiotic, we're going to be using probiotics a lot more to treat many of these conditions. Great question. Question?
What about new antibiotics?
New antibiotics.
There was a recent study that
I knew somebody was going to ask me.
in a new way of discovery.
Yeah. So there was a new study that was released in late January in the journal Nature. And this study is really exciting, but I'm going to argue that the reason why this study is really exciting is because of the method that they use to isolate a new compound that has antibacterial properties. They use chips that they put in the soil that allow many of these bacteria that don't normally grow in the lab to actually make colonies on the chip that ultimately was used to detect this novel compound. So the way that they detected this compound was unbelievable. And they did it quickly, and they were able to look at the structure of this compound, and they determined that this compound actually has antibacterial properties against certain bacteria, very similar to vancomycin properties. And it looks like this compound seems to be resistant to mutations that make bacteria resistant to it. I'm intrigued. I'd like to say that I'm hopeful. I'm very hopeful for the method. I think that method is going to be unbelievable. And I think we're going to find many different products that could be life-altering and life-changing, etc. For this antibiotics, I'd like to see more animal data and human data, but it's definitely very exciting. Thanks for that. Question?
Hi, I was just wondering, I heard about a Denmark man that had been.
I can't hear you. I'm going to move closer. I can't hear you.
Oh, sorry. I heard that the Netherlands had imposed a ban on the use of antibiotics in agriculture many years ago. I was just wondering if that had led to introduction to
So several European countries have put bans on the use of antibiotics, routine antibiotics in feed. Remember, nobody's arguing about the use of antibiotics in animals who are sick. That's a given. But removing antibiotics from feed essentially means that you're going to have to change the way you raise these animals. And changing the way that you raise these animals costs a lot of money. the European Union has imposed a ban on the routine use of antibiotics in feed for growth. And what they found, now the problem is, nobody knows whether it's been enforced or not. They don't know. But in areas where they know that the antibiotic quantities that these manufacturers are buying has declined, they've sampled the soil before and after, and they found far fewer resistant organisms in the soil in those areas than after than before. What does it mean? Perhaps it means that the decrease in use of antibiotics had a beneficial impact. But it could mean many other different things. And so I think I would caution you on that. You disagree?
The study I read, they were looking at bacteria in pigs, and resistance has persisted for several years.
So resistance in pigs, absolutely. I mean, it follows the same course as human resistance. Resistance in humans we know has lasted at least 4 weeks after a single course of antibiotics. So I will not argue with that. But what I said was an environmental sample. And that can have an impact ultimately on perhaps what gets into well water. But absolutely, in the animals themselves, you're probably going to have a minimal impact. But remember, these animals usually are killed ultimately. And so the lifespan of the animal itself is very limited. So perhaps you can still have an impact on the animal by changing by really putting a stop on the overuse of antibiotics. But again, I give you the data that I've read, and I do not try to interpret it. I leave it up there. I leave it, up there. Any other questions? Questions? Yes?
Could you speak a little to, I know some research has come out about the idea of persistent resistance, taking the full course of
Yes.
antibiotics, like the full 14 days, like whatever the manufacturer
Yes.
was.
So that's a fantastic question. It's a great way to sort of bring it back home. What can you do? What can you do to try and prevent being colonized with resistant organisms, etc.? And the answer is, I mean, you can stop eating, this, that, or the other, but ultimately, a lot of the resistance that's happening in humans is the result of antibiotics that we take for ourselves. And so what we're trying to do is change the physician's approach to treating these infections. There are 3 rules to decrease antibiotic resistance, the emergence of antibiotic resistance in individuals, in people. 1, don't use antibiotics when you don't have to. 2, use the narrowest spectrum antibiotic that you can safely get away with. There are some antibiotics that annihilate everything. And there are some antibiotics that are very targeted to certain pathogens. When it's safe, use the most targeted antibiotics so that you don't completely annihilate all the good bacteria. And the final recommendation is use antibiotics for the shortest duration possible. So we used to tell patients, we used to treat urinary tract infection for 2 weeks. We used to treat pneumonia for 2 weeks. We used to treat blood infection for 2 weeks. Because most of the studies that were done for 2 weeks. Then somebody came about and said, well, what if we just treated people for 3 days or 4 days? Does it make a difference? And for the last 15 years, people have been going to, first the drug manufacturers, and they said, let's do a study to treat people for 3 to 5 days instead of 14 days. And the drug manufacturers smiled. And they patted them on the head and they pushed them out the door. Then people went to the NIH and said, fund these studies. And the NIH said, go get the drug manufacturers to fund these studies. We're funding new research. We're not funding these repeat studies. It wasn't until about 5 years ago that the NIH decided to do these studies. And the studies that have come out since then have been, guess what? Short duration of antibiotic for most infections in most individuals. And be very careful here. Most infections, not all, most individuals, not all, short duration of these antibiotics work just as well as long duration. So now, when I was in medical school, and I'm young, and it hasn't been that long, I was taught 10 to 14 days and tell the patient to finish the course of antibiotics and not stop. And now what I teach my students, I'm now teaching my students in ID Micro. I run that course for the Hopkins students. And now I teach them, give them the shortest duration of antibiotics that is safe. And honestly, now rarely do I ever treat patients for more than 5 to 7 days with common infection. Using the shortest duration of antibiotics that we can will likely make the most difference in terms of our ability to control the emergence of drug resistance, particularly in or near the hospital setting. So now, that doesn't mean you should go home and not take your antibiotics. But I'll deny ever saying this because people will come back and say, you know what, you may have harmed people. I would say first and foremost, do what your doctor tells you. But there are a lot of doctors out there who still haven't gotten this message. And so, theoretically, for many infections, most common infections, when you start feeling better, you can stop taking antibiotics. Having said that, I'm not recommending it. I'm recommending that you talk to your doctors, and I'm hoping that your doctor will actually give you a short course of therapy. That way, you can finish your course, feel good about it, and essentially not do too much harm to your microbiome. So, don't take antibiotics when you don't need to. Use the narrowest spectrum as long as it's safe, and use it for the shortest duration of time. Question?
What do you think of the prophylactic use of antibiotics prior to dental?
So, prophylactic use of antibiotics prior to dental work. The good news is, in the past, anybody who had, for example, a heart murmur, etc., we used to give them prophylactic antibiotics. Over the last 10 years, the American Heart Association has come up with recommendations where only very few people who meet certain criteria, for example, they have very severe valvular heart disease, or they have an artificial heart valve, those people should get prophylaxis before a dental procedure. Otherwise, the vast majority of people should not be getting prophylaxis before a dental procedure. So, if your doctor follows these guidelines, the vast majority of people should not be getting any prophylaxis before dental procedures. So that's the take-home message. So unless you have certain severe forms of heart disease, you don't need it.
Having artificial hips would not count as.
Artificial hips does not count unless you have an artificial hip and back heart disease. That would count. One more question.
Bacteria or bacterial population that have the antibiotic resistance lose this ability?
So, it's a great question. Will bacteria that have this resistance, can it lose the resistance? So let me rephrase that. Most bacteria will die very quickly. But it's the generation, it's that generation of bacteria that you're talking about. And the answer is you can revert back to wild type, non-resistant. But the reversions tend to be fairly rare. And so over time, let's say you become colonized with a bacterium that's resistant. You can lose that colonization with that bacterium. Over time you can. But some people don't. Why some people lose that colonization and others don't is unknown. So the answer to your question is yes, sometimes, but perhaps not always. Does that answer your question? Again, I tried to weasel out of answering your question, but there you have it. Thanks very much.